Hello guys, and welcome to another episode of the Scrapyard Repair-A-Thon. Once again I will ask you to follow me along as I'm on the hunt for broken tools and other equipment that might deserve a second chance. We will retrieve some of these items and return to my workshop, where we will attempt to bring them back to life. This part looks like a huge screw conveyor or compactor powered by a 3-phase gear motor. Without question a valuable part, but something this heavy is expensive even when bought at a scrapyard. In this old bathtub here we find a whole assortment of partially disassembled Bosch angle grinders. We will buy the entire lot and see if we can make at least some working units out of that scrap. In the same tub I found this curious looking tool. What is that? Well, you'll see in just a minute, as I will buy this as well. Here we see a mixture of welding machines and various transformers. Mostly really basic MIG welders of questionable quality. Especially the wire feeders of these cheap machines tend to malfunction every other minute. They're not worth the repair. This is a step up or down transformer, but I don't need one since I built something like this in an earlier episode some months ago. Over here I found more broken welders, but this time they are broken stick welders with one major difference. They are of the inverter type, and that means that I can salvage valuable power electronics components from them, and that's why I will take them home as well. Over here we can find some aluminium sheets that the operator has apparently deemed too good for the trash, and he would be right about that. Unfortunately, their price here is only marginally lower than what I'd pay for new sheets. And what do we have here? Looks like an old dental drill, and that's a keeper for sure. Here I also found an old electric meter. I've recently been looking for one, and I guess it'll be interesting to have a closer look at. Let's return to my shop then. So here are all the Bosch angle grinder parts I brought to the shop. They apparently come from 12 individual machines, most of which are of the type Bosch GWS 1000, 1000 watt, 125mm angle grinders. 3 of the units are still almost complete, only that the wires have been cut off, and naturally we will start attempting to repair those units. With the remaining grinders, back covers, gearboxes, and parts of those gearboxes are missing. Some of the parts are obviously damaged beyond reasonable repair. Since the grinders have obviously been pulled apart by the former owner, all of these machines will have issues. But by combining what is left, we might be able to make at least a few working units. Let's start with number 1 then. To pull off the back cover, just one single screw needs to be unscrewed. Now the old power cable is removed. The old brushes are completely worn off. You can see that from here because what is left of those carbon brushes has completely vanished inside the brush holders. Before taking them out, I have already been looking for replacement brushes that I'm now taking out of one of the completely stripped down units. The spring is pulled out of the holder, secured next to it, and then the brush is pulled out and its connector removed with needle nose pliers. Here you can see the brushes in comparison. The replacements are about 3 times as long, having still much more material left. For an intermediate test, I'm now connecting 2 test wires to the grinder, and it has now been hooked up to my adjustable isolation transformer. As you can see, the motor does spin, but it is too slow and makes unhealthy noises. The enclosure is also heating up quickly. This tells us several things. The on-off switch, brushes, the field coil and reduction gear are generally operational, but it appears that the armature has been damaged at one point. In order to check that, the gearbox is unscrewed from the plastic part of the enclosure. Before pulling out the armature, it is almost always a good idea to remove the brushes or at least take the spring tension off of them. Otherwise, it will be very hard to later reinsert the armature. This is the rotor that is called armature in DC motors and universal motors. The rotor winding has been severely overheated at some point. It is beyond reasonable repair. We will look for a replacement armature among the remaining parts in just a minute. But before we do that, let's remove the motor shaft from the reduction gear and check if that is still okay. In the gearbox we find a set of bevel gears, in German Kegelräder. The bigger gear looks still pretty good, but there could be a little more grease on here. Inside the box we find the second bevel gear. It too still looks pretty good, but I would completely renew the lubricant in here. On top of the smaller bevel gear, on a thread on the motor shaft, we find a small self-retaining nut that we can unscrew with a wrench. The gear can now be pulled off the shaft and the gearbox can be separated from the broken armature. Among the remaining parts, I found this assembly here. The armature is somewhat rusty, but it is electrically still working. The gearbox also seems to be okay. The rust on the armature and the dirt on the commutator are easily removed with some steel wool though. And I've now opened this gearbox as well in order to check what it looks like from the inside. It as well is still looking good, so I see no point in removing the motor shaft from this reduction gear and put it onto the gear we pulled apart a minute ago. With old mechanisms that still have a good fit, I do not recommend disassembly unless absolutely necessary. After cleaning out the old lubricant, I'm applying new grease. And for your information, this might not be the best lubricant for this fast turning gear here. I'm using different lubricants throughout this video to test performance over the long term. Before reinserting the rotor, I make sure that the brushes don't block the way. Only with the armature back in place is the spring put back onto the brushes. Upon installing a new power cable and putting everything back together, we can go for a second test. And as you can see, removing rust from a rotating shaft is always easier once your machine is already back in action. So much about the first grinder, but what about the others? Well, let's inspect the other 2 or 3 models that still were almost complete. Here is unit number 2. Upon taking it apart, I find a piece of steel wool that apparently has been sucked through the air intake, essentially shorting out parts of the commutator. The steel wool probably got really hot, which damaged the plastic ring between commutator and rear ball bearing, as well as the armature winding. So in short, another busted armature. And here is unit number 3. Again, upon taking it apart, damage on the armature winding was found. And here is number 4, which, other than missing the plastic back cover, was still complete as well. Its armature still looks good, but this time the reduction gear made funny noises. Inside the gearbox we can find considerable wear on the gears. Unit 4 could eventually be saved by exchanging the broken gears with the gearbox we retrieved from Unit 1. The broken armature of Unit 2 was replaced with another still working armature I could find among the other parts. In the end, out of 12 broken units, only 3 armatures had survived in total, while all others had burned windings or damaged commutators. Buying new commutators to repair them would be non-economical, since they are more expensive here than a working used GWS 1000. But in the end, I could build 3 working units out of this heap of scrap I had bought for just a few bucks. So remember this hammer-like tool I found close to the grinders? What is it then? Well, believe it or not, this is a soldering iron, or hammer, made many decades ago by the German soldering iron manufacturer Ersa, which is, by the way, the same brand that I've been using for about 15 years now. And they still make these soldering hammers, and this one here is really of the same construction style, just not with a wooden handle. Only that the one I found is rated at over 700 watts, not 550, and that its tip is actually made from massive copper. So this must have been pretty expensive back in the day. But what could it be good for in my context? Well, just you wait. Here is one of the already partially disassembled welding inverters. But what means inverter in terms of welding machines anyway? Well, see, back in the day, most welders used line frequency mains transformers, which made these devices very heavy and expensive in materials alone. With the development of switch mode power supplies, switching converter technology was also applied to welding. With a simple welding machine being not much more than a current source for say 40 to 200 or more amps, which also needs to be resistant to short circuits, as that would be its normal mode of operation. Isolating switch mode power supplies also use transformers, but transformers that run on much higher frequencies than the 50 or 60 Hz of the line frequency. They can thus not be fed directly from an electric outlet. We're talking at around at least a few kilohertz in the early days to even the megahertz range in this day and age. For that, the mains voltage is first rectified, and from that direct voltage can then essentially be created a high frequency signal. It's chopped off with power transistors and fed into high frequency ferrite core transformers. It's then rectified again, and at least in these rather simple DC stick welding inverters, that direct current is then what you use for welding. So in short, the welding inverter turns the high voltage, low current supply of the grid into a low to medium voltage, high current source for welding. It sounds complicated, and well, in the details, it kind of is complicated. So what kind of parts can you salvage from a unit like this? Well, these components here labeled K2837 are MOSFETs. The full name is 2SK2837, and when looking for parts online, it often helps to complete that name. What we can see here is that they are 500 volts, 20 amps MOSFETs, and these are the components that will switch or chop the rectified mains voltage before feeding that into the ferrite core transformers. Unfortunately, they have been kind of drowned in adhesive, which is really annoying for me. This lower board here holds more interesting components. The black parts here are not transistors, but Schottky diodes. Schottky diodes are often used for high current, low voltage applications with high switching frequencies. Two of their strengths are a lower voltage drop, which means lower losses, and a much shorter reverse recovery time than normal universal type diodes. Old-fashioned standard diodes would be too slow to rectify the output voltage of the converter. The other components on this board are the aforementioned transformers and chokes. Heat sinks, high-power MOSFETs, Schottky diodes, and inductive components are expensive and worth salvaging. But how can we get them off this PCB with a several millimeter thick layer of solder? Well, here our Ersa soldering hammer can help. In the meantime, I have equipped it with a new power cord and it is already heated up. It heats up the thick solder layer with ease and we can retrieve the components. Traditionally, these soldering hammers were used in roofing work, as far as I know. Let's take a look at the next item then. This dental drill that I found. It's pretty old. Of that I'm sure, and the company that made it, Hebu, now Hebu Medical, has also been around for quite some time. It's one of these companies that you maybe never heard of, but they have been around for decades, and in good old German tradition the company seems to be family run, now in the 4th generation. But a fault that is visible right away here is that the little plastic nuts or caps that once held the motor brushes in their holders have cracked and need to be replaced by something. The way it is now, we talk about the mains voltage being present at these brass holders on the outside of the enclosure without any insulation at all. I'm opening the enclosure to have a look at the insides, and I can just take out the entire armature with these old-timey open ball bearings at both ends. I can't see any serious damage though. Inside the motor we also find 4 capacitors. 2 of the caps are connected in series, forming essentially one capacitor across the commutator, or rather between the motor brush holders. And then we have 1 cap each on both ends of the field coils connecting to the enclosure. These are paper capacitors, as you can also find them in old vacuum tube radios, and many people tend to replace them wholesale these days, and I will do the same here. This cap is pretty old, and I would interpret this as a date code from 1947. A proper replacement for the 2 capacitors connected between the motor brush holders could be one of these Class X capacitors. For this particular case, I'm choosing the big gray one because I had these lying around for years. I'm soldering wires to it and also apply heat shrink. In fact, I have now replaced all the wires inside the motor. And in order to hold the brushes inside their holders, I will use these nylon nuts here that fit on the M10 thread. I also put little steel nuts in there to push the springs further down. And this is what the actual handpiece consists of. Some pretty neat machining work here. The actual drill is connected to this piece that contains some kind of tiny bevel gear, just like this part here that connects to it. And then you have the shaft here that conveys the rotational movement through the inside of the handpiece or handle. I put everything back together and connected this old timer to the isolation transformer. Let's see what happens. I'd say it's a proper tool to have for the post-apocalypse. On to another item then that I brought home. This old electric meter here. Now this is something very mundane, of course, but this type of counter is actually being actively phased out right now in Germany. It still uses some rather fascinating physics and was precision made. I removed the old lead seal, take off the glass cover and put that in soapy water to be cleaned. In the meantime, we can marvel at the mechanism inside. We find an aluminium disc that can freely rotate between 2 coils or electromagnets. The coil with the few thick turns is the current coil, while the one with the insulation paper is the voltage coil or winding. They both create alternating magnetic fields that induce currents in the disc, which in turn again cause magnetic fields. These magnetic fields interact with each other, causing the disc to spin. The speed of the disc is proportional to the product of the current through the current winding and the voltage across the voltage winding. Therefore, the speed is proportional to the power used, and the number of rotations are representative of the work or energy consumed, which is stored by a mechanical counter inside. This device is called a Ferraris counter, and is basically a type of induction motor, which the Italian inventor of that name was an inventor of. The light gray fork-shaped part is an adjustable eddy current brake, i.e. a permanent magnet. The rotor is coupled to the counter by a multi-stage reduction gear, including a small warm gear. Upon connecting this electric heater, we can see that the disc is still doing what it's supposed to do, even though this counter is from the 1960s. I would like to use this meter in my shop to measure the long-term energy consumption of certain devices. For that, it would be nice though if I could reset the counter. In order to do that, I move this little aluminium retainer to the side and pull this tiny steel axle out of the frame, freeing these little gears, which fall off right away. Now I can just manually reset the counter to 0, and in order to keep it in place, I just use some tape and get the gears back in place. And with the glass cover reinstalled, I have now an electric meter that at least looks almost like new. So as always, I hope that you liked this little video, and if that is the case, then please give the video a like, letting me know to go full steam ahead with the production of more episodes of this kind. And if you want to support this channel actively, you can maybe become a supporter on Patreon. For that, visit patreon.com/tpai, or maybe make a donation via PayPal, link down in the video description. See you soon, guys.